My name is Steve. Welcome back to my shop. And in this video, I'm working on a viewer project. I introduced it in my last episode of Shark Bits, and I actually ground the tool bit that I'm going to be using in that episode also. So if you're interested in seeing the grinding of this tool bit, refer back to Shark Bits number 27, and I'll leave a link in the description and at the end of this video for that. But I want to bring you in a little bit closer and show you the details of the part that I'm going to be making, and I'll also go over the details of what I did to grind the tool bit. Here's a drawing of the part that I'm going to be making. It measures 1 3/4 inches long, is 1 inch in diameter. It's drilled and reamed to 1/2 inch inside diameter and has Acme threads at 4 threads per inch. Now for 1 inch, the normal thread count would be 5. This is 4. The first thing that I'm going to do is grind up the tool bit, which I shared in my last video in Shark Bits 27. But here are the details of that tool bit. The first thing I did was take a protractor and I measured the angle of the thread. And it measures about 13 degrees. So I needed to cut the side rake on this at least 13 degrees in order to have clearance as the bit passes through the material. And so what I set it up on my grinder at 14 degrees. Now the angle for the thread is 29 degrees. So half of that is 14.5. So on my grinding fixture, I set this angle at 14.5, and then I rotated it so that I would have a 14-degree angle here. I cut it to almost a sharp point, and then I ground the nose back until it matched the thread gauge for the 4 threads per inch. The next thing I did was hone it, all the surfaces to deburr it, and I've got a real nice polished sharp edge on all the edges, and then I ground the front nose also on it. This is the piece of stock that I'm going to be using. I think it measures 1 1/4 inches in diameter, so I have to turn it down to 1 inch, and the length on it is 2.5, and I'm going to leave it at 2.5 inches long, and when I get over to the lathe I'll show you what I'm going to do with that. So let's go mount this up in the lathe and start machining it. And I'm going to face off both ends, and then I'm going to drill it and ream it. Now I'm drilling at 31/64 to prepare for the 1/2-inch reamer. I'm going to slow it down by putting it into back gears to ream it. I'm going to mount the part on a mandrel. This is a 1/2-inch mandrel. I don't know whether you can see on it. And it has a plus on this end. And what that means is that this end is oversized. So this mandrel, the nominal size on it is 1/2 inch. It's one under a 1/2 inch on this end, and it's one over a 1/2 inch on that end. So I'm going to put the part on. I'm going to press the mandrel in so that I can machine the part. I cheated a little bit putting it on the mandrel. It was kind of tight, so I heated up the brass just a little bit. I heated up to a couple 100 degrees, and the mandrel slid right on. I'll be able to heat it up and the mandrel will drop back out. The reason I'm using the mandrel is, first of all, I can get to the whole piece. Second of all, it gives me a lot of extra space around the chuck, and the mandrel is hardened, and this turning these threads is taking a lot of tool pressure, and I was afraid that it might slip in the hardened 3-jaw chuck. So what I did is that I chucked it up in a collet, and I actually have it, each end has let me show you I have a spare mandrel here. Here it is. See, there's a step on the mandrel, and I actually have it gripped on that step with the collet, and so when it gets up to here, it can't push into the collet at all. So, because when I was doing my test piece, when I was cutting the piece of aluminum, I felt like that the mandrel was actually sliding into the chuck a little bit, and with this setup that can't happen. So now what I'm going to do is turn the piece down to 1 inch. Okay, I still got 160 thousandths to go. I'll bring you back when I'm down to my last cut. I'm down to my final cut. And while you were away, I discovered a problem. Fortunately, I found it before it was too late. Let's see if I can describe it to you. There we go. The pilot on the mandrel is not concentric with the mandrel itself, and by chucking it in the collet, by that I had a run out of almost 10 thousandths. Fortunately, I saw it, I put a dial indicator on it, so I re-chucked it into a different collet, and I have chucked it up on the ground surface, and now it's running at less than 1/1000th run out. So we're in pretty good shape. So I'll take my final cut. Okay, I'm down to size. The finished piece is to be 1 3/4 inches long, and I have set this, I left the piece almost 2 1/4 inches long, and what I'm going to do, I'm going to put a witness mark at 1 3/4 inches. Want to double check it. Okay, that's right on. Now what I'm going to do is turn this shoulder down to 730 thousandths. And where that comes from is that the thread depth on this is 135 thousandths. So double depth would be 270, and if I subtract 270 from 1 inch, it leaves me with 730 thousandths. So I'm actually going to turn this lead shoulder down to the 730 thousandths, and that'll give me a target when I'm cutting my threads, and I'll know when I reach my minor diameter. So let's cut that down. I'll bring you back when I get down to the final size. Okay, this should be the final cut. Okay, I'm at 730 on the money. Let's see if that focuses or not. Alright, now I'm going to set the lathe up for cutting the threads.